Consider the following graph. With points now, can you tell me what the values of the first derivatives, what the signs of the first derivative and the second derivative are at these points? It's understood y is a function of x here. Now at point A, what is the sign of f prime of x? It's an easy question. Positive, because it's upward sloping. If you draw a tangent line at point A, you see that that tangent line has a positive slope. So obviously the sign of the first derivative is positive there. What about the second derivative at point A? Andra? Oh, now what would it mean for the second derivative to be positive at point A? It would mean that, what? What would that mean? What does it mean for the second derivative to be positive? What's that? What does that mean about the rate of change of the first derivative? The second derivative is the rate of change of the first derivative at a point. So a positive second derivative means the rate of change of the first derivative is positive. It means it's getting bigger, doesn't it? As x gets bigger, the first derivative gets bigger. Is that true in this case, though? What is happening to the first derivative at point A? Is it getting bigger or smaller? Yeah, if you pick a point just slightly to the right of A, what is happening to the slope? It's getting less steep. So if it's getting less steep, that means as x gets bigger, f prime of x is getting smaller. So the second derivative at point A is actually negative. Okay, do you all see that? At point A, the value of the second derivative is actually negative. Because if you pick a point just slightly to the right of A, the slope is going to be less. If you pick a point slightly to the left of A, the slope is going to be greater. Okay. Now, what about point B? At point B, what's the sign of the first derivative? What does it look like? Adam? Zero. Yeah, it looks like I meant to draw this so that it's right at the top of this little hill. So at point B, the value of the first derivative is 0. What about the value of the second derivative, Adam, at point B? Okay, again, what is the second derivative? It measures the rate of change of the first derivative. So, Adam, no. If I increase the value of x just a little bit, we're at this point right here now. We're at x0, the critical value of x. If I increase x a little bit, what happens to the slope? Yes. Becomes, it actually, to the right of B, the slope becomes negative. Because this is at the top of the hill. So if you go a little bit beyond the top of the hill, you're going down. So the second derivative, again, at point B is what? Negative. Okay. Notice, had we gone a little bit to the left of B, had we decreased x, the slope would have become positive. So, in other words, x, the value of x and the first derivative are going in the opposite direction. So that's clearly a negative rate of change here. So here, the second derivative at point B is also negative. Okay. At point C, what is the sign of the first derivative? Negative, okay. Clearly, you draw a tangent line at point C, has a negative slope. What is the value of the second derivative at point C? Negative. It's still negative because if you increase x a little bit, the slope becomes even more negative. So it's decreasing. Okay. So it's a negative rate of change. At point C, if you increase x a little bit, the slope becomes even more negative. Okay. So the second derivative is still negative here. Now, what about at point D? At point D, obviously the first derivative is negative. What about the second derivative at point D? It's not real obvious, is it? What you're asking is, if we increase the value of x a little bit, does the slope become more negative or not? And I tried to draw this so that at point D, the value of the second derivative is actually 0. Okay. That is where, in other words, at point D, that is where the slope becomes most negative. Okay. All right. So the value of the second derivative here is actually 0. Now, what about point E? Obviously, the first derivative is still, anybody? Negative. Okay. What about, at point E, what about the sign of the second derivative? Positive. Right, because it's obvious by the time you reach point E, if you increase x a little bit, the slope is becoming less negative. You're getting close to this bottom here. So the second derivative is positive there. Okay. At point F, what is the value of the first derivative? Point F is right here. Anybody? 0. And what is the value of the second derivative? It's still positive, yes, because if you increase the value of x a little bit, it goes from 0 to positive. So the value of the second derivative is positive there. And finally, at point G, what is the value of the first derivative? Positive. And the value of the second derivative looks like the value of the second derivative perhaps is still positive there. That if you increase x, the slope becomes more positive at that point. But it's not exactly clear. Okay. All right. Now, where's your max? Well, you have one relative maximum right here at point B. That's a relative maximum. Notice what you have there. First derivative, that's 0. Second derivative, negative. That conjunction, first derivative being 0, second derivative being negative, guarantees that you have a relative maximum. Now, it's a relative maximum, not a global or absolute maximum. It's just a maximum. At point B, you have a maximum in a neighborhood around x sub 0. If you draw a small neighborhood around x sub 0, in this neighborhood, you have a maximum here. It's a relative maximum. Okay. And what do you have at point F? A relative minimum. And notice at point F, first derivative 0, second derivative positive. This combination guarantees that you have a relative minimum. But notice one more thing about this graph. I intended it to indicate this. It just continues. Let's just assume it continues to go down in this range. And it continues to go down in this range here. In that case, the global maximum is actually up here at point H. The absolute maximum, or the global maximum, is actually at point 8. H. Okay. So there is a difference between a relative maximum and a global maximum. Okay. In this case, there are two relative maxima. At point B is one, the other is at point H. Okay. You have one local minimum at point G. But if these functions continue to go down forever, then the global or the absolute minimum is not really defined. Okay, all right. Okay, does this